One second, Niels, let me go ahead and introduce the webinar.
Sorry.
Today is June 30th, and this is the 2015 Facilities Geospatial Technology Showcase. This 6-month webinar series is hosted by the Campus Facilities Technology Association and organized by the University of Kentucky. I'm Michelle Ellington, and thank you to all attendees joining us today. Today's webinar is being recorded. Both the recording and slides will be made available on the CFTA website. The presentation is estimated to run 45 minutes with the remaining time dedicated for Q&A. Feel free to send any question during the presentation using the questions dialog box. Your question will be added to the queue and answered at the end or as time allows. I want to extend a special thank you to today's presenter, Niels LaCour. Niels serves as a senior physical planner at the University of Massachusetts Amherst, and today he will be presenting on how the university is using GIS as a decision support system and the integration methods they've invested in to meet their goals. Niels, thank you so much for being here today.
Thanks, Michelle. As you can tell, I'm anxious to get going with this presentation, and I want to first apologize to everybody that tuned in on May 26th. Unfortunately, we had a router go out just before showtime, and about 15 buildings lost network and internet connections. So I do apologize for canceling on that. To start, I really do want to thank Michelle and also Lauren from the University of Kentucky for hosting this seminar series, and really want to say thanks also to all the other presenters in the series. I personally have found this to be a very valuable, inspiring, and motivating set of work to keep us working towards building a smart campus. It really seems like we've come a long way from when I first started work at UMass 8 years ago and was part of the listserv at that point in time. And I remember a several-day email exchange about GIS and CAD and one technology versus the other and the virtues of both. I think we've come a long, long way from that. Today, I would like, instead of saying one technology versus the other, really talk about the data, the power of data interoperability. And I want to do this from a planner's perspective. So, and talking about, first talking about all the pieces of the puzzle that make up our institutions and sort of the reasons why we are pursuing the tools for decision support. Talk a lot about why data interoperability, and then really take a deep dive into the feature manipulation engine and it's give you a better idea of what that tool is and all the power that it has, and talk a little bit about working toward dynamic data-driven reports. And then hopefully, if we'll have time, we'll show some other examples of interoperability and other tools. So as we all know, a university is a set of systems that combine to make up a very large, complex organization. And in some senses, we're a small city where we have our own infrastructure, utilities, and we also have an awful lot of people here doing things, and very interesting things that have a variety of needs. So if we take a closer look at these systems, we can start to get an idea of the level of complexity and magnitude of the systems we're dealing with. So for instance, here at UMass, we've got about 35,000 people on any given day here, and another 14,000 sleeping over. In the last decade, we've averaged about $150 million a year in new construction, deferred maintenance, renovations, and building IT infrastructure. We offer 200-degree programs and 7,000 course selections in over 400 classrooms. We have 12.8 million gross square feet in a lot of buildings on a 1,500-acre, close to 1,500-acre campus with a lot of infrastructure. We deal with 7,000 of tons of waste annually. We're very excited about the fact that we recycle about 56% of that annually. We also serve over 40,000 meals a day for this people here. And it takes a lot of energy. We spend about $26 million a year, 2 trillion BTUs in just 2013. So it's a big operation, about $1 billion a year. We are the flagship campus of the UMass system, and we, as planners, we are working to try to support those decision makers. We do this by engaging in the continuous cycle, or sometimes I like to call it the spiral of planning, where we help establish the vision, identify the needs, identify assets to help meet those needs, do the analysis that we need to find, solutions, present a lot of different options, do some of the facilities programming and planning to find out what kinds of buildings we need, how do we fit in those buildings, or whether we can fit in existing space that we already have, help people develop the capital funding requests, and of course, hopefully implement a lot of this planning efforts, and around we go, and hopefully the data and information that we're dealing with can help make better decisions, because I firmly believe that good data is essential for making good decisions, and it needs to be provided in a way that helps decision makers. Now, how do we deal with all data? Again, we take a very systematic approach. We look at the campus as systems, and all of our education efforts and research and operations depend on all of these systems to be fail safe every day, even though we did have a network out last time. Anyway, if we look deeper into these different systems, we can quickly see that all of the different pieces really represent a lot of different kinds of data. So from the examples from Excel spreadsheets to BIM models, from photos and textures to space data in Tririga. And I'll also show an example where we bring in some of our HR personnel and scheduling data as well. But a lot of different types of data. So how do we bring all this disparate data together and make it useful for decision makers? So we'd like to apply some principles of integration. First of all, it's got to be reproducible. You have to be able to create and then recreate models. They've got to be easy, maintainable, easy to introduce changes or fork scenarios or tweak something. And I'll show an example of that a little bit later on. We certainly are working towards data-driven models. We would like to be very much format agnostic, although we tend to try to bring everything within the GIS environment. We want to make sure that they're workload-driven, so that we can automate them and minimize the manual operations that happens. I often call Dr. Alexander Stepanov the optimizer, because he's automate, 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 and that's really important. We also want to make sure they're comprehensive, that we can deal with all the multiple existing data sets that we have out there. And so how do we do this? Well, in the past, I've often used this slide as sort of the quick introduction to the data interoperability extension, or FME, where you have, which is an extract, transform, and load program. So you have all of these things that can take the different formats of data. You have the tools to be able to do transformations on that data, and then you can carefully put that data into the destination. And it's a great tool for documenting your workflows. I have to say, Michelle is a wonderful beacon of light for documentation, and that's part of what I love about this program, is it documents everything. But today I really want to take a much deeper dive into FME, which is produced by Safe Software out of Vancouver, British Columbia. And it is an incredible, powerful program that has serves us in many different ways. So first of all, you have all of the spatial and non-spatial data formats that you need to deal with. All of the GIS stuff from SDE, ArcGIS feature services, ArcGIS Online, all of that typical GIS data that we have to deal with. But then all of the sort of architectural information that we usually get in CAD files, BIM, or Revit models, or SketchUp, or all the text that's included in AutoCAD drawings, as well as the relational database management systems, programs like Access, Excel, SQL Server, all of just the pure data information that we need to deal with. And then, of course, there's a ton of other miscellaneous data out there, from images to just XY points to unstructured text, and now, of course, we have an awful lot of information coming in from Twitter and social networks as well. So to be able to have access to all that data and be able to bring it into our system is really important. And this is where we get into the fun part of using the transformation, the pieces of the puzzle that you have there. There's over 400 different transformers that come out of the box in the feature manipulation engine. Some of the ones that we're going to talk about here today are the feature merger, joiner, PDF page formatter, PDF styler, the mapnik rasterizer, and so forth. And so we'll get into a little bit about how we do those, but it's amazing the amount of manipulation that you can do with this data as you take it from one data source and carefully put it into the other data source. This has come an awful long way from DXF out and DXF in, which I remember what we used to have to do, and you just prayed and hoped that everything got there where it was supposed to get. Now we have all these transformers, and we can very carefully put into the destination all of that information, whether it needs to come into ArcMap or City Engine or Tableau, or whether we're going to just use it as developing reports like we'll show you a little bit later, and then being able to serve that up over the web. How do we take all of that information and turn it into actionable information for our decision makers? I'd also like to show you the sort of graphic user interface of the FME Workbench. This is a really nice tool, whereas you have up here the typical Windows menu and toolbar they give you. Over on the upper left-hand corner, you have the navigator window, so this gets you to all the pieces and the parts of FME. And then really the heart of the program is really the canvas that you're working with. And it's all done in a graphic format, so you grab your extractors and put them here, and you draw a line. So again, you document your whole workflow and work process as you're going along. Over here on the right, you have your entire transformer gallery, a list of all the different transformers that come out of the box. You can get information and descriptions of those transformers as you sit over here in number 5. And then as you run through and you can test the project and run through it, you have a log window. And so this will show you if you run into any errors, what the results are. So it's a really wonderful interface for building these workflow-driven processes. Now, we're going to get into a little bit about how we get into data-driven reports. And you have this wonderful little mapping, open source mapping program right in FME, which allows you to define the rules for rendering. It's a very highly customizable rendering engine, and you can basically use it to automate the production of maps and pre-render reports. So here are some of the examples of taking all these different kinds of data and telling it how you want to display it on a map or in a report. You can also, again, in defining your reports, set up templates and define the rules for how you're going to, where you're going to put the different pieces of the information that you're bringing in. And then, finally you have your page formatter that allows you to drop in your pre-rendered components, your data layers. It's got all the placeholders for all the different other pieces that you need. And there you go. And I'll get into showing you some of the examples of the output from that in a little bit. But while we're sort of in the process of really looking at all of the data and all the different things and how it all works, I also want to show a couple of examples of how you can use FME to get at some of the other kind of data. This is an example from several years ago where we were taking data out of one of our surveyors who's retired a few times already, and we're still trying to download his brain. He's created an AutoCAD drawing from all of his experiences on working on the campus that has over 6,000 notes of work, and those notes contain everything from what the materials were used in the utilities to what contracts were used. So you can see down here it says C, the University Contract 702-2 with a date of 1955. And so there is a lot of information within those AutoCAD drawings. And how can we harvest that information? So here's an example of how you can use a string searcher within FME and set up regular expressions so that you can search for patterns. So we know that a date or the contract number has a certain set of letters and numbers in a kind of pattern that will give us a contract number. And so being able to use these regular expressions within these searches really allows you to learn once and reuse again and again. So we use the same approach to extract a lot of the utility attributes from the CAD attribution layers, so that once we capture that information, we can then bring it in and attach it to the database of these different utilities. And so you can see this in our GIS data viewer, what you can do, and then also use a lot of that information to then give us the link to where those drawings are that have been scanned and archived within our archives. So a lot of times that text stream will also give us most of the information we need to create that data link. We have also used this process in the past in trying to use Rectilinear Steiner minimal trees and looking at taking our AutoCAD floor plans and creating a network, circulation networks out of them to be able to do 2D and 3D routing, evacuation planning, look at accessibility options. So one of the really wonderful things in FME is the ability to have access Python and Python libraries. So in this example, Dr. Stepanoff was able to bring in a Python script that was able to implement the MSD transformer. So for 21 rows of code, implemented this and was able to create from a set of floor plans a tree that gave us the network to get around the buildings. So getting back to space planning, and I realized that while I had a special thanks on my title page to the folks in our space planning division, I really want to give a special shout out to them because they do such a great job in terms of giving us really good, clean data to bring in our GIS data. So a lot of our space planners that are working on the space database are Roxanne Verity and Nagara Prashadi and Lindsay Kinney, who really do all of the work of maintaining that authoritative data source. And every and also I can't forget Matthew Goulet from our ANF Systems, who provides them a lot of technical support, and then Pam Rooney, who is the manager of that division. Ever since we've started developing our CAFM system, these guys have done a great job of making sure the floor plans are in great shape and all the data is up to date and ready to go. Now, I was very happy that when we had Jonathan Contract also in that group, who unfortunately has now moved on, he helped us develop and use FME to hopefully give them a whole lot of help in terms of bringing in new buildings. So now a lot of our new buildings, as they come in, they're required to produce BIM models for the buildings. And so how can we get the floor plans into our space management system from Revit? So again, here's where the feature manipulation engine is incredibly important. And it allows us to identify all the different layers that we want to bring in, because we certainly don't want to bring in the whole models. We have a typical set of how we like to have our CAD drawings done, so we can define what those are and just extract those pieces that we need them. And then we can automate this process. And it's probably saved thousands of hours of human time, people's time, because in the past it used to have one of those guys would have to polyline all of the different polygons for each space and make sure those are closed polygons, and that took forever and ever. Now they can spend a lot more of their time working with the rest of the data and doing a lot more of the planning stuff. So our space management program is Tririga, which recently got bought out by IBM, and it is our data, it's our authoritative data source for all of our space data. So in it you can have all of the information about buildings, floors, personnel within it. It gives you the capability of looking at each of the spaces and finding out all the information and data on those spaces. You can also look at floor plans and color them by a variety of attribute information. Unfortunately, one of the big drawbacks is really only being able to look at one floor plan at a time, which has been part of the motivation for us to then extract the data out of this system and then bring it into the GIS so that we can look at this kind of data across the whole campus all at one time. Tririga also has abilities to do space data and reports and put out all that data into reports. We have developed some custom reports as well, but there are some basic things. But one of the most important components that our space staff worked with our consultants to develop was an online survey. So in the past, that crew had to go out and basically interview all of the folks in the departments, survey all of the rooms and everything all themselves, and that took a lot of time. And basically we were able to survey the whole campus once every 3 years. It was basically a 3-year cycle. Now with this online space survey, the department folks themselves can fill out the survey, and then our space data folks can then take and review the data and make sure it's all correct and get it in. And so that time process has gone from a 3-year cycle to survey the whole campus to being able to do that on an annual basis. So that's been great to know that our data is much more up to date and hopefully a lot more accurate than it has been in the past. So that's been a great tool, and luckily we have a great crew there. And one other interim measure that we've taken to sort of make that space data more accessible to more people, because unfortunately the seats for Tririga are fairly expensive. And so one of the ways we've gotten around that is to use SharePoint as a site to be able to give other people access to the data. So here you can do searches on the buildings, you can get a list of some of the reports, and this was all developed by Matt Goulet, who is in our A&S Systems group that provides a lot of technical support for campus planning and space management. So you can also see you can get access to the floor plans, both in a DWG format as well as PDF format. So just through this little dashboard here, you can get access to an awful lot of the information that folks are looking for about space on campus. Now, I also want to thank Mohammed Abdullah, who is part of our planning and programming group. He, along with Dr. Alexander Stepanov, who's our GIS architect, and then also Lukasz Czarnicki, who's an architectural graduate student working with us in campus planning, have really been working a lot on, so how do we take all of this data and make it much more usable for decision makers? So this is some example of Mohammed's work in taking, he's a newcomer to the GIS world, but has embraced it completely, even done one of his master's projects using the technology. But he's also got a great graphic skill. And so how do we take some of those GIS maps and bring them into some other graphics programs and start to try to find ways to bring that data a little more alive to people and make it more sense? So in this example, we were needing to demolish Bartlett Hall, which is here down in the red. Hopefully we can demolish it before it falls down on its own. And we're looking on where we want to put a replacement building. So what kinds of classrooms and facilities are in that building, and where are they in relationship to the other assets that we have on campus? In the end, we're now putting an addition onto the historic South College, and the proximity of that works well with the different departments that are going in there, and all of the analysis that we were able to do. And I know a lot of folks enjoyed this sort of newer approach to trying to take that information and make it a little more visible on a map. Now I'd like to get into some of the work that in terms of the data-driven reports that Jonathan had initially started off on, that luckily Lukasz and Alexander Stepanov have taken and done a lot more work with. So this is the FME workflow for basically creating a legend on the map and taking all those different components and putting them together, taking the floor plans, taking the data out of that has been exported out of Tririga, pulling it together, telling it how to render those different floor plans, and then how do you take all of that stuff and put it together on a map, and where does the different components go onto the map. So here you have the report assembly. So you've got your template and all the different places and placeholders where things are supposed to go. And then your FME workflow says, okay, take this piece, put it there, this piece, put it there, and in the end, you get a report. So I know a lot of folks, this looks like a very simple thing, but when you're having to do hundreds of these reports for across the whole campus, being able to automate it so that you can click on a button and let it chew for a few hours and then produce a PDF file with several hundred of these reports in is a pretty amazing thing. One of the nice, as my father said, there isn't anything so bad it isn't good for something. In the end of May, we were just had almost finished this process, hadn't quite made it all work yet. Now I can happily say that we have figured it out. It all actually works. It works well, and now we are even actually doing a lot of things to improve some of the workloads and just make it look better graphically. So now you can see the numbers on the floor plans a little better. You can see that we've added some of the square footages that each organization. This effort, these reports were all part of a student life experience master plan that our GIS group was helping to support on campus. So we wanted to know where all the different organizations that support student life had their space on campus, and it's across hundreds of buildings on campus, and we needed to know that. So being able to hit the button and be able to crank out floor plans where each of those places has space and know how much space has been quite an achievement. So looking at some of the other examples of how we're trying to help visualize data, Tableau is one of the fastest growing business analytics software out there, and so in trying to explore what those tools, Dr. Stepanov has used his FME magic again to take our data and put it into that format. So as you can see, the default Tableau map service is not relying on a lot of the typical vendors and doesn't have a whole lot of information, certainly not as much as we have here on campus. So how do we bring our GIS building footprints into the Tableau shapes, and how do we bring the centroids of those buildings into XY coordinates into Tableau? And this is an example of the FME workflow to bring any polygon line geometry into Tableau. And it converts the building's footprints from a GIS representation into an SQL table, and represents the line by storing the shape ID, the point sequence, and the lat long coordinates. So it's interesting. Sasha notes that the most complex part here is the vertex counter transformer, and that was available as a free custom transformer from the FME store. which meant he spent no time programming it. So it's pretty wonderful to be able to take all these different pieces and plug them into the process. But here you can see that now we've brought in the building footprint in the Tableau, and it's ready to get connected with the data tables and run the analytics. So here's where we brought in our data from our R25 scheduling software. And so this is a somewhat abstract view of where all the students are at 10 o'clock on a Thursday morning in the fall semester. What's interesting here is you can see one of our smallest buildings is Mahar Auditorium, but it contains a couple of our largest lecture halls. And so even though it's a very small building, it really shows up big here on the thing. So it gives you an idea of where people are on campus during a given time at the day. And I know we're all interested in exploring a lot more techniques into where we bring in this scheduling data and take a look at it and what that can do for us as planners. So here's another example of the dynamic data-driven report. And so we spent several weeks to a month probably developing the workflows to do the reports for the student life master plan. And now, after having finally perfected that, Lukasz was able to take all of that workflows that he developed within FME for that process and tweak them somewhat so that now we're using this process to take a look at all the lab spaces on campus. So within a matter of days now, suddenly we're able to take this set of workflows and tweak it so that now we can take a look at lab space on campus and where are all the labs located. And so to a lot of folks, these kind of reports are very important. This is how they look at the world. We're also trying to figure out other ways to provide that information to people in a way that can help them make decisions that make sense. So we are certainly looking at City Engine and how we can use this 3D technology. So here you can see straight down view from in City Engine of all the lab spaces on campus, and then now let's extrude that into the 3D and bring up those spaces. And one of the things we wanted to do here is being able to have that data attached so that you could sit in a meeting with all these reports, with this stuff live on a screen and say, where are these things? Where are they in relation to other things? And then I think most importantly about having this kind of interface is being able to then click on a particular space and get access to the attribute information over to the right. So we're starting to explore with different ways to visualize that space on campus. I think we're far from figuring out the best way to do it, but we're certainly exploring some ways to take a look at this kind of data. So that wraps up the presentation part of what I had, and we certainly have time for some questions. I'm very happy to say that Dr. Stepanov is here next to me because he's the real brains behind the FME work that we do here. So I guess we can open up for questions now.
Great. Well, thank you so much. I know that I have a personal affinity for FME. I know I used it extensively 15 years ago doing U.S. Army Corps of Engineer DGN conversion, the whole DXF in and out. I'm very familiar with that. And but for that work, we were using DGN, bringing in all the levels and migrating those over to SDSFIE file formats and conversion to the electronic navigation charts. A lot of standardized formats, many formats. So my question for you is, if that was 15 years ago and it was a very solid application, and I'm sure more and more formats have come in since then, where do you see are any limitations in the formats that FME offers for your modern day geospatial needs?
I don't really see too many. I think they have rightly anticipated the need for much more robust 3D capabilities, which I know they've introduced in the last version, and they're doing a lot more with 3D. But they've really stayed a step ahead of the game, and I think my hat's off to those guys at Safe Software because
so that's very impressive. So all of the City Engine, Revit models, all of the current day formats are all within FME environment?
Right, that's one of the latest things that they've given us is the direct read-write for Revit and BIM models.
Fantastic. Now, what about, for those out there that want to get started with FME today, what would be the recommendation of the suite that would be of interest? Do you have a desktop, or are you with server? Do you use a professional edition, or can you answer that?
Well, I would like to first say that if for those Esri folks out there that have the Esri software, FME is really you get an awful lot of FME just within the data interoperability.
Data interoperability, yes.
That comes with our GIS. So you can start having fun with data interoperability right through there, and that provides an awful lot of, probably the majority of the functionality there. We quickly went on to the server version because there was so much that we wanted to do with it. But you can also go to safe.com to their downloads and check things out. And there's an awful lot of videos and tutorials that are free for the research. We have found those guys to be incredibly helpful in terms of working with educational institutions, and it's just a great corporate culture, and they want everybody to be successful, so it makes them easy to work with. But I think certainly data interop extension is the first step. The desktop will then give you an awful lot of, we have three licenses of the desktop as well, and then because we use it so extensively and we're migrating so much of our stuff to the web, then we also have decided to go ahead and get the server version.
Oh, that's interesting. I personally have never used the interoperability extension. One thing I find is very interesting is, when you do work for government and huge contracts, they are different than working on our universities and some of these smaller projects we have. But as the universities and the campuses are growing to really be these repositories of huge geospatial libraries, that's changed. And we do need to know how to, produce hundreds of reports, hundreds of data sets, and to keep the information current and dynamic and savvy with technology. So it's changed. We do need to become more efficient with these tools. So with data interoperability, I recall the interface looks a bit different than FME, doesn't it?
It is more or less the same. It is really the same.
Really is the same.
Yeah, and Sasha just passed me a note that also emphasized that FME desktop is a hidden gem. So I guess the advice would be to look carefully before you move to each of those steps and see what you can get out of it, because you got a lot of power at every stage.
Okay. So there are some functionalities, it sounds like, that are different between desktop and interoperability, and so just to really examine those differences for each use and to make that decision. That's wise. Okay, I have a couple of questions out here for you. The first one is, how long have you been using Tririga, and did you consider other products, and is it cost effective for your organization?
We have been using Tririga now for we began implementation, I believe, about 3 years ago. We did go through a very lengthy process to acquire the technology, and with not always the greatest results. We actually worked with Manhattan Centerstone to begin with. Then we found that their initial pilot project wasn't as successful as we had hoped, and that's when we then made the decision to go with Tririga and then also hire an implementer. So I think in a lot of ways it was very important for us to hire an implementer for it. We felt that Tririga was the most robust. Looking at it as an enterprise piece of software, we thought that Tririga was probably the most robust and could do the most in the long run that we had. Now, it is a fairly complex program and does need an awful lot of customization to meet our needs, which is why we ended up hiring a BRG group out of Texas, and they have been fantastic in terms of working with their implementation. So we have fully implemented the space modules and space planning modules, again, thanks to our great space planning team. But we're also now in the process of implementing the asset management piece of the software. It is expensive, but again, it is also very robust and very powerful. And we basically, a sort of shout out to Esri and their wonderful educational licenses for us really allow us to then use the GIS as a good platform to disseminate a lot of the information, which is part of the reason why a lot of these workflows are so important, because we really feel that GIS is by far the best environment to help visualize and analyze a lot of the information. But Tririga is our database of our authoritative database, our database of record.
Okay. I have a question here about the slide you showed, showing the short code for making a RSMT look like it took an already existing campus network. The question is, how did you create that original interior network?
I'm looking across at the table to my colleague, Dr. Stepanov, and hoping he will explain.
But mainly that method is actually extracts internal skeleton or routing from the building, connects rooms and corridors, and then we add vertical connections, and then we can connect outdoor networks.
Does that, so the program itself figures out where the centroid of the room is and where the corridors are. Does that answer the question, I hope?
I hope. that question was from a gentleman, Jonathan Kusick. So hopefully that satisfies his question.
Well, anybody is happy to contact us offline as well, ask further questions. So.
Okay. Just got another question popped in about the Tririga connector for Esri GIS, and if you are using that.
Yes, we are. Matt Goulet is providing support for that, and we are working to implement that piece with, actually, this is just hot off the press, just going, so I'm not completely familiar. What is it? Oh, you had a meeting about it today, right? Yeah, unfortunately, Matt Goulet, who's not in the room with us, would probably be the best person to answer that question. So I would certainly welcome somebody emailing me at nplacour@cp.umass.edu with any other questions they want to ask, and we can get you an answer. But I know we are just starting to work with that piece, and that was, again, one of the reasons why we initially went with Tririga, is because they were one of the early. I was pretty blown away, 6 years ago when I realized how far apart the worlds of CAFM and GIS were, and how neither world seemed to know the other was out there. And Tririga was one of the first to start their implementation with GIS, but I think all of the big players in the game have followed suit now.
Okay. Okay, well, April says thanks, so you answered her question very well. You know, I think that concludes the questions for today. I have many for you I'd like to ask you on the side about FME. You know, one of the things is that, you know, there's many ways to skin a cat. I think a lot of people use Python, they use Model Builder, they use List, they use custom programs to have the same output. And with FME, if I'm understanding it clearly with your purpose, you like it because you don't necessarily need to be a programmer, right? You can just build a model and you can perform an action that's simple or very robust without being a programmer. Is that
That is absolutely true, and Lukasz is a prime example of that. Lukasz is finished his undergraduate degree in architecture here at UMass and had started working for us after that. And he's so skilled graphically that we wanted to keep him on. So we basically handed him City Engine and got him to start working with that. But now recently we've handed him FME and said, all right, we need to work on these workflows. And within a couple of months, he has taught himself how to do FME and how to build these very complex, the wicked webs they weave with that program. It's pretty amazing. So Lukasz does not come from a programming background at all, but luckily he is not afraid to dive into something and get into it. So it's been very impressive to see how quickly he's been able to learn some of the basic fundamental things and then build some pretty complex workflows out of it. And again, I just love the documentation, right?
Yeah, if I recall correctly, too, you can save the Workbench files out and then just like kind of relink sources to them, so they're very easily shared. Is that correct? Yes,
that is correct.
Yeah, and I think that, you know, the data interoperability recommendation is huge. I remember that collaboration happened like I think over 10 years ago when Safe Software was implemented as part of Esri. And it hasn't really gotten too much attention. I think not as much as it is worthy. So hopefully this presentation will get everybody, myself included, out there clicking around with the extension, because we are more so under the Esri education program model. So we have those tools readily at our disposal, more so than purchasing a new desktop application. So thank you for your presentation today to kind of get those wheels turning. And unless any other questions come in, we'll go ahead and just end here a little bit early.
Well, I'd like to say a quick thank you on that note, Michelle, about learning. I'd like to also say a quick shout out to Mike Park at MIT. We stopped by his offices 6 years ago, and my colleague Sasha, Dr. Alexander Stepanov, he saw FME there, and that was it. He saw what it was, looked at what it could do, and he hasn't looked back since. And it's just gone to town with using it for, it is such an integral part of everything we do here now in terms of our GIS world. So I can't say enough of it, which is why I wanted to take this opportunity to do a little bit of a deeper dive into FME rather than just showing that one extract, transform, and load slide, because it is a lot more to that.
And I recall it being extremely easy to use, much easier to use than Model Builder. You can dive in very deeply to all the attributes and the levels and the domains that you can quickly manipulate with your mouse click as opposed to any programming. So very excited to get back into it. So thank you for that. And I do want to go ahead and just wrap things up. Thank you, Nils and Alexander.
You're welcome.
So much for today. It was a pleasure having you. This does conclude the 2015 Facilities Geospatial Technology Showcase. I'd also like to thank all the attendees who joined us today and have helped make this webinar series a success. If you would like to view this webinar or any previous webinars in this series, please visit the CFTA website at www.cfta.org. Thank you so much.
Thank you.